This is Module 5, Lesson 27. In this lesson, we'll be comparing fractions greater than 1 by creating common numerators and denominators. Let's start with 3 3/8 and 3 3/4. And we're going to compare to see which of these two numbers is greater. In this particular instance, both the whole numbers are the same, so we can kind of discount those and just look at the two fractional parts. In this situation, we see that the numerators are the same. So if we have 3/8 and 3/4, and we know that 8s are smaller than 4s, we know that 3/8 must be less than 3 3/4. We can show that with a tape diagram by first showing 3/4 and then drawing a same sized whole number as our tape diagram, but this time we're going to divide it into 8s. And we can see that 3/4 is greater than 3/8. We could further prove this by dividing our 4s again into 8s and see that 3/4 is actually equal to 1, 2, 3, 4, 5, 6 8s. And 6/8 is greater than 3/8. So once again, 3 3/8 must be less than 3 3/4. Let's look at a whole number, 4 3/4, and a fraction greater than 1, 23/5. Now, in this circumstance, right off we can see that one of the numbers is a mixed number, one is a fraction, and the two denominators are unrelated. So we can't easily do this. So let's start by first turning the number that is a fraction into a mixed number. So 20/5 plus 3/5 would be 35/5. 20/5 is equal to 4. So we have 4 3/5. And again, we have the same numerators. So if we have 4ths and 5ths, we know that 4ths are greater than 5ths. Therefore, 4 3/4 must be greater than 23/5. We could show this another way by actually converting the fractions to the same denominator. So if 23/5 is equal to 4 3/5, we're comparing 3/4 and 3/5 since the whole number parts are both the same. So we could show 3/4 in an area model. And we could show 3/5. And now we could, as we've done before, multiply the two denominators together to get 20. And we could decompose each of these fractions into denominators of 20. So 5 times 4 is 20. 3 times 4 is 12. And for 20 here, 5 times 4 is 20, so 3 times 5 is 15. So 3/4 would be equal to 15/20, and we can show this on our area model. So we now have 20ths, and we see 15 of them are shaded. And over here, 3/5 is equal to And if we count, we have 12/20ths. And so again, we can see that 3/4 is greater than 3/5. So 4 3/4 is greater than 23/5. So we can show this multiple ways. Let's look at another instance of a mixed number and a fraction greater than 1. In this instance, we could go the other way, and instead of converting the fraction into a mixed number, we also know how to convert the mixed number into a fraction. So to show 3, we would need 30/10 plus 7/10 would be 37/10. And 18/5, 5 and 8 are related. We can multiply both the numerator and the denominator by 2 and get 36/10. 37/10 is greater than 36/10. So 3 7/10 is greater than 18/5. Let's try some problems in our problem set. So for the first one, we're drawing a tape diagram to model each comparison, and then use greater than, less than, or equal to compare. So try A on your own. So for A, our whole number parts are the same. So we're going to compare our fractional parts. And we'll start out with 2/3. And then we'll show the same size whole divided into 6 and shade 5/6. And we see that 5/6 is greater than 2/3. So 2 2/3 is less than 3 5/6. Try B. For B, again, the whole numbers are the same, so we're comparing 2/5 with 6/10. So we have 2/5. We have 6/10. And it looks like 6/10 is greater than 2/5. We could further check by dividing the fifths into tenths. And we'll see that 2/5 is equal to 4/10. And this is 6/10. So 3 2/5 is less than 3 6/10. Try C. Again, our whole numbers are the same, so we can compare the fractions. One way to do it would be, we know that 3/6 simplifies to 1/2 as a benchmark fraction. So 1/2 is greater than 1/3. We could also draw a tape diagram. And show 3/6. And another tape diagram. And show 1/3. Then we could divide the thirds into 6 to see that this is 2/6 and this is 3/6. So showing a different way that 4 3/6 is greater than 4 1/3. Try D. Okay, for D, before we can proceed, we need to either turn our mixed number into a fraction or a fraction into a mixed number. So let's turn this into a mixed number. So 16/4 would be equal to 1 with 3/4 left over. So this would be equal to 4 3/4. So now our whole number parts are the same. Let's look at our fractional parts. So we have 5/8 and 3/4. So our drawing looks like 3/4 is greater than 5/8 on our tape diagram, but to be sure, we could divide our fourths into eighths and see that we have 6/8. So in fact, 3/4 is greater than 5/8, since 6/8 is greater than 5/8. Therefore, 4 5/8 is less than 19/4. Okay, moving on for number 2, we're going to use an area model to make like units. So pause the video and try A. So for A, we're going to change our fraction into a mixed number. So 14/7 plus 4/7 would be equal to 18/7. So this would be equal to 2 4/7. So our whole numbers are the same. So now we're comparing 3/5 with 4/7. Our denominators are unrelated, so we're going to multiply them to get a common denominator of 35. So 3/5 would be equal to, in 35ths, 5 times 7 is 35. So 3 times 7 would be 21. And here, to get 35ths, we're multiplying by 5. 7 times 5 is 35. So 4 times 5 is 20. So we see that 21 35ths is greater than 20 35ths. So 3/5 is greater than 4/7. In an area model, we have 3/5, and we're going to decompose again 7 times. And if we count, we have 21 35ths over here. We're going to start with 7ths. And we have 4. And now we're going to decompose by 5ths. And if we count, we have 20 35ths and 21 35ths. So going all the way back to our original, 2 3/5 is greater than 18/7. Try B. So for B, we already have mixed numbers and our whole numbers are the same. So we're comparing 3/8 and 1/3. Our denominators are unrelated, so we're going to multiply them to get 24. So to convert this fraction into 24ths, we're multiplying by 8. And to convert this fraction to 24ths, we're multiplying by 3. So we see 9 24ths is greater than 8 24ths. So 2 3/8 is greater than 2 1/3. As an area model, we have 3/8. And here we're going to divide into thirds. And then we're going to divide again into thirds here so that we end up with 1 2 3 4 5 6 7 8 9 24ths. And here we'll decompose by 8. And when we count, we have 1, 2, 3, 4, 5, 6, 7, 8, 8 24ths. And again, our comparison shows us that 9 24ths or 3/8 is greater than 1/3 or 8 24ths. Okay, for number 3, we're going to still use greater than, less than, or equal to, and we can use any strategy. So try 3a. In 3a, our whole numbers are the same, so we're comparing 3/4 and 3/8. Our numerators are the same. So if we have 3/4 versus 3/8, we know that 4ths are greater than 8ths. So 5 3/4 must be greater than 5 3/8. Try B. Again, our whole numbers are the same, so we're comparing 2/5 with 8/10. One way would be to say 2/5 is less than a half and 6/8 is greater than a half. So 5 2/5 is less than 5 8/10. We could also, since 5 and 10 are related, we could change to the same denominator by decomposing by 2 and get 4/10. And comparing 4/10 to 8/10, we see that 4 2/5 is less than 5 8/10. Try C. Okay. For C, one strategy would be to decompose this into a mixed number. So 25/5 plus 2/5 would be equal to 5 2/5. And again, we could use the same logic that 6/10 is greater than a half and 2/5 is less than a half. So 5 6/10 would have to be greater than 27/5. We could also change 2/5 into tenths by decomposing by 2 and getting 4/10. So 5 4/10, again, less than 5 6/10. So 5 6/10, again, greater than 27/5. Try D. For D, the whole numbers are the same, so we're going to compare the fractions. The denominators are related. We can multiply by 5 to get 15ths with 2/3, and we get 10/15ths, which we're comparing to 9/15ths. 10/15ths is greater than 9/15ths, so 2/3 is greater than 9/15ths. Try E. For E, our numerators are the same, so when we look at the denominators, we see that halves are greater than thirds, so 7/2 would have to be greater than 7/3. Try F. For F, neither our numerators or denominators are the same, and the denominators are not related, so we're going to need to find a common denominator by multiplying. So 12/3 would be multiplied by 4 to get to 12ths. So we'd have 48/12. And 15/4 we'd multiply by 3 to get to 12ths. So we'd have 45/12. And 48/12 is greater than 45/12, so 12/3 is greater than 15/4. Try G. So for G, I'm going to first turn the fraction into a mixed number. 20/5 plus 2/5 is equal to 4 2/5. And now my whole numbers are the same. So comparing 2/5 to 2/7, fifths are greater than sevenths, so 22 fifths would have to be greater than 4 2/7. Try H. Again, let's turn the fraction into a mixed number. So 20/4 would be equal to 5 plus 1/4 would be 5 1/4. Compared to 5 2/5. Both those numbers are, both 1/4 and 1/5 are less than a half. So we can't really just make a decision based on that. The denominators are unrelated. So let's multiply them to get a common denominator of 20. So 1/4 decomposed 5 more times would be 5/20. And 2/5 decomposed 4 more times would be 8/20. So 5/20 is less than 8/20. Therefore, 21/4 would be less than 5 2/5. Try I. Once again, no easy way because of related denominators or the same numerator and denominator. So we're going to multiply to get a common denominator of 24. So 29/8 we could make into a whole number of 24/8 plus 5/8 would give us 3 5/8. And for 11/3 we could do 9/3 plus 2/3 would be equal to 3 2/3. So our whole numbers are the same. So we're going to compare 5/8 with 2/3, and we said we wanted to have denominators equal to 24. So if we turn this into 24ths, 8 times 3 is 24, 15 times 3 is 15, 5 times 3 is 15. And again, over here to get 24ths, we multiply by 8. So 2 times 8 is 16. 15/4 is less than 16/4. So 29/8 would be less than 11/3. Try J. For J, we're going to compare the fractional parts since the whole number parts are the same. The denominators are unrelated, so we're going to multiply and get 28 as a common denominator. To turn 3/4 into 28, we're going to multiply by 7 and get 21 28ths. And we're going to multiply 7 times 4 and get 16 28ths. So 21 28ths is greater than 16 28ths. So 4 3/4 is greater than 3 4/7. And that's the end of lesson 27.